Okay, looks like I have some of the kinks out of the recording. I'm just posting part one, which was this last problem, and then I'll go through and do the rest of this now and give it to you to look at, and then do the homework that I emailed to you. So let's go ahead and look at the next problem. This is a good one. It says here we have this picture, some kid playing a violin, and she's 10 feet above the line where the light is, and this guy wants to shine a light right on her face and blind her while she's trying to play her violin solo there. And so it says here, the main character in a play is playing a solo, and the lighting technician needs to shine a spotlight into the actor's face. The light being directed is attached to the ceiling that is 10 feet above the actor's face. Okay, so the height above is 10 feet, and at an angle of 20 degrees, how far from the actor should the light be? So, in other words, um, well, we can look at a couple of things here. The light's 10 foot away. Well, how far back does it need to be if it's going to shine down at a 20-degree angle? Well, in this case, we have this scenario. We have the kid here with the violin, right? And we've got the light. She's 10 feet above where the light is. The light's over here. Does a light look like? I don't know. Some light shining down. And that beam is shining right in the kid's face. This is 20 degrees. So let's figure out this distance here. How far that light needs to be away if that's 20 degrees. Okay. Um, Easy enough. So we know opposite over adjacent. That's the tangent. So the tangent of 20 is going to equal the opposite, 10 over d. And then we can also figure out this length as well, which we'll go ahead and do that. So tangent of 20. Tangent of 20. And that's 0.364. 0.364. And that's equal to 10 over d. And just switch places. So d is going to be 10 divided by 0.364. And let's see what that comes out to be. 10 divided by 0.364. And so this distance is 27 feet away. Okay. Now, the rest of the question, let me get rid of this. The rest of the question says, what if the lighting technician wants to shine the light at an angle of 30 degrees and 32 degrees? No. Oh, and by the way, if we want to get this length, we can use Pythagorean theorem. 10 squared plus 27 squared is equal to that length squared. Just take the square root. So, so he's at a 20-degree angle. Well, how far should the person be if they want the angle to be 30 degrees? Okay, so at 30 degrees, what should my D be? Or at 32 degrees? Well, let's take a look and try it at 30 degrees. Again, the height is still going to be 10, but if I come a little closer, I'm going to have to shine the light a little bit. The angle is going to be greater. So again, we're going to use the tangent of 30 is going to be the opposite over the distance. So the tangent of 30 is 0.577. So 0.577. So I'm going to switch the D into 0.577 and do the math. If you want to see what I just did there, I'm just saying, well, hey, my angle, you had to move closer, and my angle is 30 degrees. What is the distance now? Excuse me. So let's go down and do 10 divided by 0.577. And the distance is 17.3 feet. See, gets closer, he has to shine the light down a little bit more. And then if he gets a little bit closer, the angle's 32 degrees. Then we would just use the tangent of 32. So let's get the tangent of 32. Same, want to take a look. See, now I'm going to just do 32 degrees. So the tangent of 32 is equal to 0.624. That's going to be equal to 10 over D. So I'm going to take 10, switch the D in the 0.624. 10 divided by 0.624. And that gives me a D of 16, roughly 16 feet. So you can see that as the closer I get, the larger my angle of depression has to be. Okay, let's take the calculator down and see what else they're asking us here. This drawing's not to scale, but let's take a look at it anyway. It says an airport is tracking the path of one of its incoming flights. The distance to the plane, from the plane to the airport is 850 feet. So your hypotenuse here is going to be 850 feet. And the altitude above the ground is 400 feet. What is the sine of the angle of elevation? Okay. Now, what is the cosine of the angle of elevation? What is the tangent of the angle of elevation? And finally, what is the measure of the angle of elevation? So here's our drawing, which is not to a very good scale. Here's our airport, and this is the information that was given. They ask about the angle of elevation. Well, the angle of elevation would be this angle here. So in other words, how many degrees above the ground is my angle? If I was looking at the plane flying in this direction, the angle of depression would be that angle there. And if you notice, these are like alternate interior angles. If I'm bisecting, if I'm cutting through rather perpendicular lines, if you remember that from geometry, this would be your angle of depression as the plane is looking down. And if I'm looking up from the ground, that's my angle of elevation. So I think they asked all sorts of different things. What is the sine, the cosine, and the tangent? Well, first of all, let's figure out what this leg is here. So we know that the hypotenuse is 850. So first of all, let's write our a squared plus b squared is equal to c squared. And we know c squared is 850 squared, and a squared is 400 squared plus b squared. Let's solve that for b squared. So I'm going to just pull up the calculator again, minimize my face, and let's just clear all this stuff out of here. Clear, clear, clear. Oh, come on, don't jam up on me. Okay, well let's do 850 squared. The old Old calculator's dead here. Not even going away. All right, I'll do it on the other calculator. Let me get the screen back up. Sorry about this. This is one of the pitfalls of live recording with technology. So I'm going to do 850 squared and then subtract 400 squared. So 850, 850, square that, minus 400 squared, and I get b squared is equal to 562,500. So I want to square root both sides of that. And I get 750. So this side is 750. As I said, the drawing's not a good scale. It's not really the scale. So that's just the way it is. So they want the sine of this. Well, the sine is going to be opposite over hypotenuse. So the sine of my angle is going to be 400 over 850. Okay, and we can reduce that. We can call that 40 over 85, and we can reduce the numerator and denominator. So we got 8 and 85 is going to be what, 17? Yep, 817, 8 over 17. So that's the sine of our angle. We just reduced it. And the cosine would be adjacent over hypotenuse. So the cosine of your angle would be 750 over 850. And if we want to reduce that, that's going to be 75 over 85. So divide the top and the bottom by 5. So that's going to be 15 over 17. So that's the lowest ratio there. Reduced the lowest point. And the tangent of your angle, tangent is going to be, tangent of my angle is going to be opposite over adjacent, or 400 over 750, or 8 over 15 if you reduce that number. So those are all of your things. Then finally, what is the angle? Well, we could choose any one of these ratios and take the inverse of that. Let's just go with sine, because you have the sine of your angle. The sine of your angle is 8 over 17. Now, if we look at our button, we have the arc sine. Looks like that, sine minus 1. Okay, and it should be the second function of your sine button if you have a calculator like that. Let me pull up the broken calculator. And it's still jammed, but whatever. But if you see, here's my sine button. If I go second sine, it would give me my value. So I'll do that right now for you. So I'm going to put the number in here. And since the sine of the angle gives us a number, the inverse of that function, arc sine of the number, gives us the angle. So I'm going to go sine minus 1, 8 divided by 17, and my angle here is 28 degrees. 28 degrees. So these are the way we use our trigonometric ratios to help us with these various things. Okay, let's see where we are on our problems. Probably get another one done or so. All right, this is a good one. We have the Leaning Tower of Pisa. And if you've ever been to Italy, it's a nice Nice thing to see, but not worth the effort because it's in this little town of Pisa, and basically all there is the Leaning Tower and a little chapel where you can. It's kind of neat because it's designed acoustically, where you can hear all around the place what people are singing or saying because of the design, the sort of parabolic reflector uh, that is the roof. But anyway, let's take a look at the picture of the Leaning Tower of Pisa, and it says, okay, here's my Leaning Tower. I'm gonna kind of exaggerate it a little bit. And then they always have the tourist who stands in front of it like they're pretending to hold it up and they take the picture. It's so cheesy. So if we drop a perpendicular, what we know that this would be the right angle. I'm just dropping a plumb bob down from the top of the Leaning Tower of Pisa. This angle here is 16 degrees. 16 degrees. That's quite a bit. Um, and they're telling us that this is 175 feet. They want to know um, how high is this famous structure. Actually, according to this diagram, I wonder if they mean that this is 175 feet, and they want us to get this distance here. Yeah, because that would be the actual height of the structure. So I think what they're saying in this picture is they're saying, okay, my plumb bob here is 175 feet, and they want you to calculate the actual height of because this would be the height of the tower of Pisa, the Leaning Tower of Pisa. So what do we have here? We have an adjacent side, and we're looking for a hypotenuse. So adjacent and a hypotenuse, cosine is adjacent over hypotenuse. So I'm going to do cosine of 16 degrees, and that's equal to the adjacent 175 over the hypotenuse, which we don't know. We'll just call it h for the height of the tower, or the hypotenuse of the tower. So again, like I said, I think they mean this is the height of your plumb bob. So we're going to solve for the height of the tower. Cosine of 16, and then switch these two around. Cosine of 16 is going to be pretty close to 1. It's 0.96. So we've got h is 175 divided by 0.96. And the tower is standing straight up. If this tower was standing straight up, the height would be 182.3 feet. 182.3 feet. Okay, so that's another trig problem. All right, take a look at a couple more. A ladder makes an angle of 48 degrees with the ground. How long is the ladder? It's a pretty long ladder if he's climbing up 12. If the height of the ladder hits 12 miles above the ground, let's solve it anyway. Silly problem. Trying to climb to I don't know where. So let's sketch this. All right. We have a building that apparently is 12 miles high. And then our big giant ladder coming down to the ground, my right angle there. And I forget how it's a 48-degree angle with the ground. Wow, this is a goofy problem. So this angle here is 48 degrees, and they want to know the length of the ladder. So I have an opposite. I'm looking for a hypotenuse, so we're going to use sine. So the sine of 48 degrees is going to be equal to 12 miles over h. So the sine of 48 is 0.743. and that's equal to 12 miles over h. Switch the h and the 0.743. H is going to be 12 miles. It's a goofy problem. Divided by 7.743. So the length of your ladder is 16.1 mile. That's a big ladder. That's a big ladder. And I think finally we're ready to wrap it up here with another example, and then I'll turn you loose on your problems. It says find the angle of depression from the lighthouse to the buoy. Now the angle of depression, I'm going to sketch this problem, then I'll put it on full screen. They have a lighthouse here. Got a lighthouse little thing there, window, and to the buoy out here. I'll just put a little triangle like that. We know that the height is 208 feet, and we know that the horizontal distance to the buoy is 500 feet. And they want the angle of depression. Let's go back and talk about the angle of depression. So here's my lighthouse, 208 feet high, 500 feet in a distance from the buoy. Now the angle of depression, that's supposed to be parallel to the ground. Okay, that doesn't look very parallel. So we draw it. That would be the angle of depression. Okay. Now, if we can get this angle, we know that that plus that has to equal 90 degrees. Right? Because think about it. If I have a rectangle and I draw a diagonal, this whole angle is 90 degrees. So this angle plus that angle has to equal 90 degrees, right? So let's find that angle and then subtract it from 90. We have an opposite and we have an adjacent. So I would use tangent for that. So the tangent of my angle is going to be 500 over 208. You can leave the units off because they're going to cancel. So I'll do that. I'll get the tangent. Tangent of 500 divided by 208, and that's 0.041, 0.042. Okay. Now I'm going to do the inverse tangent, put that number in, and I'm going to come back out with an angle. So inverse tangent, and that can't make sense. Wait, hang on, something goofy's here. Let me double check everything. Let me double check. Opposite over adjacent, that should be my tangent. So the tangent is, oh, I made a mistake here. That was the tangent. The tangent of theta, of your angle, is going to be 500 over 208. Made a little mistake there. So what I have to do is I have to put this number into my calculator. I was hitting the tangent button there. This is the tangent. So the tangent minus 1 of 500 over 208. Yeah, let's go ahead and do that. So tan minus 1, 500 divided by 208. And I get 67. This angle here is 67 degrees. So this angle here has to be 23 degrees. Or no, wait, 13 degrees. 23 degrees, because they have to add up to 90. So 67 plus 23 is going to be 90 degrees. Yep. So that's how you do these problems. They're just using the ratios between different things and figuring out what you need to solve. So, excuse me. Work on that tonight. If you have any questions, email me and watch these two videos. I'm going to post them, email them both to you. So have a good evening, and I'm sorry I can't be with you tonight. And I know that you're probably happy about that. That's okay. So you guys have a good evening. See you tomorrow. I should be well by then.